Hi Year 6 and welcome to Ratio in under 10 minutes. I hope this short video gives you a little bit more confidence to tackle those tricky ratio problems. So what is ratio? Well, ratio is an area of maths which looks at the relationship between two or more things, and that can be objects, that can be numbers, and we're going to look at some examples right now. One thing you need to note from the start is ratio is about using our multiplication or division, but never addition and subtraction. Enjoy the videos, and if you have any questions at the end, just ask your teacher.
Let's start with a scaling problem involving shapes. In this case, we're being asked to write the ratio of side A and side B on these two separate triangles. What you have to imagine is that the first triangle has been enlarged using multiplication to make the second one. Our job is to simply identify the change that has happened. So, looking at side A, you can see that it passes through 1, 2 squares. Now let's look at the same line in the second triangle. This time it passes through 1, 2, 3, 4, 5, 6, 7, 8 squares. So I can write this ratio in a couple of ways. The first thing to do is to say that goes through 2 and that goes through 8. So we'll write that as 2 to 8. And that's mathematically correct. However, I could also acknowledge that the 2 has turned into 8 by being multiplied by 4. So it's become 4 times bigger, and I can write that as 1 to 4. Which basically means for every 1 square in the first triangle, there's now 4 in the second one. Interestingly, if I had looked at a different side of the triangle, I could still get a correct answer. So for example, on this one is 1 long. But in this one it's 1, 2, 3, 4. So again, I could write that as 1 to 4. Or in this example at the bottom, it's 2 along the bottom, and it's 8 along the bottom here, 2 to 8. 2 to 8 and 1 to 4 are equivalent ratios because in each case, you've multiplied the first value by 4. Now, let's look at this ratio problem. Amina planted some seeds. For every 3 seeds Amina planted, only 2 seeds grew. Altogether, 12 seeds grew. How many seeds did Amina plant? Now, when we've got word problems like this, it's easy to get a bit lost in the words. So let's make some notes to make things a little bit simpler for ourselves. I'm going to put a little S to represent the seeds that she planted. And then I'm going to put a little G to represent the ones that grew. We're told at the top here, the ratio, that every 3 seeds that she planted, only 2 of them actually grew. So that is the ratio between the amount of seeds that were planted and the amount that grew. And that ratio always stays the same, even if these numbers get larger. Now we're told that altogether 12 seeds grew. So under G for grew, I'm going to write 12. And I've been asked how many seeds must have been planted. Now, one way I can do that is to look at the change that's taken place from 2 to 12. And remember, in ratio, we never use addition or subtraction, we use multiplication or division. So this 2 has been multiplied by 6 to become 12. That ratio has to stay the same for the amount that we planted in the first place. So we must multiply that 3 by 6 to get 18. So we now know that if 12 grew successfully, then Amina must have planted 18. So 18 is your answer. Now let's look at another ratio problem, but this time it involves 3 separate values to play with. David and his friends prepare a picnic. Each person at the picnic will get 3 sandwiches, 2 bananas and 1 packet of crisps. The children pack 45 sandwiches. How many bananas do they pack? Now what we need to notice here is that these 3 values, this is a ratio. So I'm going to put headings like we did in the last word problem. S for sandwiches, B for bananas, and C for crisps. We're told that for every 3 sandwiches, we'll get 2 bananas and we'll get 1 packet of crisps. So that's an example of a ratio with 3 separate values. Now we're told that the children packed 45 sandwiches. So if I go to S for sandwiches and below put 45, I'm actually being asked how many bananas they packed. not being asked about crisps, so I won't worry about that for now. So like we did on the last problem, I'm going to look at the change that's taken place here. So for sandwiches, what do I have to multiply by 3 to get up to 45? Well, the answer there is 15. But if you couldn't do that mentally, you could have written out your multiples of 3 or counted up from the highest multiple of 3 you knew. So that change of being multiplied by 15 has to take place for the bananas too. So 2 lots of 15, or 15 lots of 2, is 30. So the amount of bananas they packed must have been 30. Now I'm sure some of you are sat there wondering about the amount of crisps. We don't need it for this problem, but you can see there would be 15 packs of crisps too. Now, here's a really similar ratio problem to the ones we've had before. It just looks different. 2 matchsticks have the same length as 3 bottle tops. How many bottle tops will have the same length as 50 matchsticks? Again, this can be a bit overwhelming with all the words and the pictures, so let's put it down into some simple notes. Let's look at a simple ratio. So I'm going to put an M for matchsticks, and I'm going to put a B for bottle tops. The amount of matchsticks is 2, and for every 2 matchsticks we know there are 3 bottle tops. That ratio always stays the same. So when we're asked how many bottle tops will be the same length as 50 matchsticks, I'm going to pop a 50 over here for the matchsticks, and I'm going to think about the change that's taken place. I know that to figure out how many 2's go into 50, that's the same as halving 50, which is 25. So again, I'm going to do the same thing to my amount of bottle tops. I'm going to do 3 lots of 25. 25, 50, 75. 3 lots of 25 is 75. So how many bottle tops? That's this number, 75. Now I thought I would finish this video on ratio by looking at a ratio problem that actually links to our fractions work. In a class, 18 of the children are girls. A quarter of the children in the class are boys. Altogether, how many children are there in the class? Well, I quite like the bar model for this problem because it helps me to visualise what's being said. In a class, 18 of the children are girls and a quarter of the children are boys. Well, if I know we're talking about quarters here, I'm just going to draw a bar that's split into 4 equal parts, just to help me to visualise this. Okay, there are my 4 equal parts. I'm told that a quarter of the children are boys. Now suddenly that makes it really clear to me that these 3/4 must be girls, and I'm told that that value is 18. So if that's 18, I must divide it by 3 to figure out what 1/4 is. 6, 12, 18. That then makes it really clear to me that the remaining quarter must also be 6. I can then do 4 lots of 6, or just do the 18 added to the 6, and I get 24 altogether. Coming back to the overall problem question, it asks me how many children are in the class. So it's 24 children altogether.
There you go, Year 6, that's ratio in a nutshell. I hope that was helpful for you and that made some sense, and I hope that you can use some of those strategies in your SATs. Good luck and all the best.